Greetings everyone, I'm BATIANCILA and I'm representing the class design for our disaster response system. This system models responders, missions, communities, and supplies, using object-oriented principles like inheritance, association, and composition. Let's take a closer look at how these classes interact. First, we have the person class, which is abstract. It contains general attributes like ID, name, and sex that are common to all individuals. Since it's abstract, we cannot create a person directly. The responder class inherits from person. This means each responder is a person but has additional attributes such as assigned zone and list of missions. The multiplicity of this is 1-to-1. Next is responder and mission. A responder can participate in multiple missions, which is represented by the mission list. Each mission, however, is assigned to exactly one responder to the responder reference. The multiplicity of this is 1-to-many. Next is mission and community. Each mission targets one community, represented by community attribute. A community can be involved in multiple missions over time. The multiplicity of this is association, 1-to-1. Next is mission and supply batch. Each mission requires one exactly supply batch, represented by the batch attribute. The multiplicity of this is 1-to-1. Next is supply batch and supply item. A supply batch is composed of multiple supply items stored in the item list. This is composition relationship. The life cycle of supply item depends on the batch. The multiplicity of this is 1-to-many. Thank you.
Greetings everyone, I'm ASUNCION and I will discuss the person, responder, and community class to our simple disaster response system. This system helps manage responders and communities and evaluates their performance and priority. Let's start with the person class. This is an abstract class, meaning it cannot be directly instantiated. It serves as a base class for other types of people in the system. It contains ID for unique identifier, name for person's name, sex for gender. It also has a constructor to initialize the data. Getter methods like getID, getName. This class promotes inheritance so other classes can reuse these attributes. Next, we have the responder class, which inherits from person, additional attributes, assigned zone for area where responder is assigned, missions for a list of missions handled, key methods, add mission, mission M, adds a mission to the responder, get performance score. It serves as calculates the average efficiency rating, formula total efficiency divided by number of missions, returns 0 if no missions, and to string. Displays responder name and performance score. This shows inheritance and aggregation. Responder has many missions. Now let's go to the community class. This represents an area that may need help. The attributes are name for community name, population for number of people, risk level for danger level, urgency index for how urgent the situation is. The key method is update urgency in change, increases or decreases urgency level, get priority score, calculates how urgent the community needs help. The formula used is population times 0.5, risk level times 2, urgency index times 3. This means higher population is equals to higher priority, higher risk is equals to more weight, and higher urgency is equals to most important. The string displays community name and priority score.
Greetings everyone, my name is Shane DADULLA and today I will explain all the constructor used in our Java program for the supply batch and supply item classes. First is a supply batch. This class is designed to manage a collection of supply items, like a batch or a group of supplies in an inventory system. It keeps track of multiple supply item objects and can calculate the total value of the total weight of everything in the batch. First, we have the class itself. Class supply batch list supplies items is equal to our new array list. This declares a class named supply batch. Inside the class, we have the main field called items. It is the list that can hold objects of the type supply item. We initialize it right away with the new array list that creates an empty list ready to store supply items. This is where they store all the individual supplies items that belongs to this batch. Next, we have the the public void add item, supply item add item. This method is called add item. As the name suggests, it allows you to add the supply item object into the batch. It takes the one parameter, a supply item called item, and supply adds it to our item list using the add method from the array list. This is how you build up the batch by adding this item one by one. Now, the public double get total value. Double total is equal to 0. For the for supply item, items total plus or equal that total value return total. This method is called get total value. It returns a double or a decimal number representing the total monetary value of all items in the batch. It starts with the total 0, then it uses the enhanced for loop to go through every supply item in the item list. For each item, it calls the item on total value method and adds to the running total. And finally, it returns the grand total. This is the great example of delegation. The supply batch doesn't calculate the value itself. It asks each supply item to calculate its own value and then sums them up. Similarly, we have this method, public double get total weight. Double total is equal to 0 for supply items items total plus or equal that total weight and return total. This is almost identical to the get total value, but instead it calculates the total weight. It loops through all items, call each item's total weight method, adds them up, and then returns the total weight of the entire batch. Next is the supply item class. This class represents a single type of supply item, like a box of pens, a pack of batteries, or any inventory items that has name, price, weight, and quantity. Public class supply item, string name, the name of the item, example, the batteries, double value, the value of the price of the unit of the item, double weight, the weight of the unit of the item, int quantity, how many units are in this supply item entry. This field stores the basic information about each supply item. Now the most important part, the constructors, public supply item, string name, double value, double weight, int quantity, this that name is equal to name, this that value is equal to value, this that weight is equal to weight, this that quantity is equal to quantity. This is the parameterized constructor. It takes 4 parameters and initialize the object. When you create the new supply item, you must pass the name, value per unit, weight per unit, and the quantity. This that keyword is used to distinguish between the class fields and the parameters that have the same names. This is the only constructor in the class, so every supply item object must be created with these 4 pieces of information. Next, we have 2 very useful methods, public double total value, return value times quantity. This total value method calculates the total monetary value of the supply item. It multiplies the value of the unit by the quantity. For example, if one item costs 5 pesos and you have 10 of them, total value will return 50 pesos. Public double total weight, return weight times quantity. Similarly with total weight, calculates the total weight of all units of this item. It multiplies the weight of the unit by the quantity. This is why the supply batch class could easily sum everything up, because each supply item already know how to calculate its own total values and total weight.
Greetings everyone, I'm DEVERA and I'll be discussing the mission in the main class. So, in the mission class, it represents a disaster response mission assigned to a responder for a specific community using a batch of supplies. It has private attributes for the responder object, the community object, and the supply batch object, along with the distance, difficulty, and time taken, which store key mission details. The constructor of the class initializes these attributes using the provided parameters and immediately adds the mission to the responder list of the missions through r.add_mission_dis, ensuring that each responder keeps track of the mission they are assigned. The compute cost method calculates the total cost of executing mission by summing several factors. The total value of the supply batch.get total value, a weighted base cost calculated by multiplying the total weighted by 2, a distance-based cost by multiplying the distance by 5, and a difficulty cost by multiplying the difficulty rating by 100. This provides a comprehensive estimate of mission expenses. The get efficiency rating method evaluates how efficiently the mission is being executed by comparing the total supply value against the time taken plus 1 and then subtracting the difficulty factor. This gives a numerical measure of how well resources are utilized relative to the challenge. Finally, the summary method returns a formatted string summarizing the mission, including the name of the community, the computed cost, and the efficiency rating, providing a quick overview that can be used in reports or summaries. Overall, the mission class integrates the responder, community, and the supplies into a cohesive unit while providing methods to calculate cost and performance, allowing the disaster response system to monitor and evaluate mission dynamically. Now let's move to the main class. The program begins with the main class and its method, which is an entry point of the disaster response system. The first line prints a header to indicate the simulation is starting. In TC1, the program creates a new community object called C1 representing Zone A with 1,000 people and urgency level 8 and 9, and the responder object R1 with ID 1, name 1, gender M, assigned to Zone A. These objects are then printed to confirm their creation. In TC2, a new supply batch is created and items such as food and water are added using supply item object, each with specified quantities, weights, and type codes, followed by a confirmation message. Moving to TC3, a mission object M1 is created, assigning R1 to assist C1 using the supply batch, along with the parameter like distance, cost, multiplier, and urgency factor. And the message confirms that the mission has been assigned. So TC4 calculates the cost of the mission by calling compute cost and prints it formatted to 2 decimal places, while TC5 measures the mission efficiency using get efficiency rating and prints it similarly. In TC6, the urgency of the community C1 is updated by 2 points to reflect changing conditions, followed by confirmation message. TC7 calculates the community priority score using get priority score, helping the system decide which communities require immediate attention, and TC8 evaluates the performance of R1 through get performance score, showing how well the responder is handling missions. In TC9, a supply item medicine is added to the batch, and TC10 recalculates the mission cost to reflect the updated resources. In TC11, demonstrates scalability by creating a second responder R2 assigned to Zone B and confirms the addition. Finally, in TC12, 12 prints a summary of the mission using m.summary along with the current states of both responder and community, providing an overview of all the operation. And that's all for the main class.
Now let's move on to the output of our program. First, we have the header, disaster response system. Then we see the several log messages with test case number. They show the actions a system is performing in sequence. Let's go through them one by one. Test case 1, created community zone A, created responder who 1. Test case 2, created responder who 1. Supply batch created with items, food and water. This means that the supply batch was created and it contains at least 2 supplies item, the food and water. Test case 3, mission and created and assigned who 1. A mission was created and given to the responder named who 1. Test case 4's cost is 1,170. This shows the total cost or value of the supplies for the mission. Test case 5's efficiency 113.79. This is calculated efficiency score. Test case 6 urgency updated. Test case 7 priority 549. The system updated the mission's priority to 549. Test case 8 performance 113.79. Performance value is shown again. Test case 9 added item medicine. A new supplies item called medicine was added to the batch. Test case 10 new cost is 1,890. After adding medicine, the total cost increased to 1,890. Test case 11 added responder Pedro. A second responder named Pedro was added to the system. Then we have a clean summary at the end. The mission is going to Zone A. Final total cost of supplies is 1,890. Efficiency score is 213 approximately. One has a score of 213.79, meaning he is actively assigned and performing the mission. Pedro has score of 0. He has added but not yet assigned to the mission. Zone A has a priority level of 549. So as you can see, the program successfully creates a disaster zone. The Zone A creates responders Juan and Pedro, builds a supply batch with food, water, and later adds medicines, creates a mission and assigns it to Juan, calculates total cost, efficiency, and priority, updates the system dynamically, finally prints a nice summary showing the current states of mission responders and the zone.